Hi everyone, welcome back. Let's look at surds again, but in a different way. This time, they can see a bit more justification for what we're doing, especially when you have to do calculations with them. If you multiply by the square root of 5, square root of 5 is a horrible number to divide by. It's not a nice number like 2 or 3, it's a horrible number to divide by. So if I get the same calculation, if I multiply anything by 1, for example, if I multiply 7 by 1, I get 7. If I multiply 10 by 1, I get 10. So when I multiply by 1, the actual calculation stays the same. I can multiply anything. I can multiply 6x times 1 and I just get 6x. So it stays the same. If I multiplied this by, let's say any silly thing for a moment. Let's say I went 2 on 2. 2 on 2 is just 1. So if I multiply that by 1, what it does is it keeps it the same, but is it of any use? So if I multiply by 3 on 3, it keeps it the same, but it's what I talk about all the time is it rearranges. But when I rearrange that, is that going to be helpful? And the answer is no. So the only one in this case that's going to be helpful is if I multiply it by a root 5 on a root 5. Remember, anything divided by itself is 1. So that just means that I've still got the same answer as 1 on root 5. But let's look at what's happened. Multiply the tops and multiply the bottoms. So you've got 1 lot of root 5 is root 5. Now we could take our time and go root 5 by root 5. You multiply the insides. So that's the square root of 25. So actually what we've turned this into now is root 5. And square root of 25 is just 5. So if I wanted to actually do the calculation now, it's easier to calculate dividing by 5 than it is dividing by square root of 5 that we had originally. Here's another interesting thing, is that now is the same as that. If you pick up your calculator and you go 1 divided by square root of 5 and you go root 5 divided by 5, it's the same, it can't calculate, same answer, same number. So you start look at it and you go, yeah, okay, that makes a bit of sense to it. Are we going to use him in calculations? Yeah, a lot of people will, a lot of places. There'll be a lot of people that don't, but this is part of your higher level maths. So if I multiply this one also, what I've done is make it a little bit more complicated. What instead of a 1 I had a 3? Well, the same principle applies. It's still times by root 5 on root 5, which is still multiplying by 1. So on the top now, multiply the tops and multiply the bottoms. I've got a root 5 by root 5, which is root 25, and hopefully you start to realise that a square root times itself eliminates the square root. So they're called square and square root because they are, really we talk about they are the opposites of each other. Opposites, they cancel each other out, just like you can talk about left and right, up and down, addition, subtraction. But then we make it a little bit more complicated. If you wanted to, you could go 2 root 5 and 2 root 5 and have a look what happens. But the students who do that tend to make a lot of mistakes. We're not worried about the 2 being on the bottom, we're only worried about the root 5. So if I want to get rid of that square root of 5, I can multiply it by root 5 and root 5. And let's have a look at what we've got and see what it's done to the question. Multiply the tops and multiply the bottoms. So the tops now are 3 root 5. Now a root 5 by a root 5 is a 5 times another 2 is 10. So hopefully you can follow that quickly. What if I make a square root on the top? It's basically the same question, but just going a little bit harder each time. So I want to get rid of that root 5 on the bottom, so I multiply by root 5 again. I can have other numbers, which I'll do in a second. So the top becomes 3 5s are 15 because you multiply the insides of the surds can go together. And the bottom's root 5 by root 5 is root 25, which is just 5. So brainwashing with 5s, let's just go different numbers. I don't have to multiply by 3 root 2, I could just multiply by root 2 on root 2. And we're away from 5s. Let's have a look at what we've got. This is a 2, normal 2 on the outside. By the way, there's a 1 there. So I could go 2 1s are 2, and they're the outsides. And inside the square roots, root 3 by root 2 is root 6. Let's have a look at what we've got on the bottom. A root 2 by a root 2 is a root 4, which is just back to a 2. So what is a root 2 to a root 2? Cancels it out. So that's a 2 times 3 is 6. Then people go to cancel this 6 and you can't. This 6 is on the inside and this 6 is on the outside. You can't cancel it. but these are both even. So I can go 2 into 2 goes once, 2 into 6 goes 3 times, and I've ended up with 1 root 6, which I can just write as a root 6, and the bottom I can write as just a 3. So all we're doing is rearranging surds that are fractions